Hello viewers, in today's class we are going to discuss one important integral, right? And here we have to find the value of this integral in which we have 0 to infinity and the integrand is t raised to 4 e raised to minus t, right? So in this class we'll try to find out the value of this integral using the concept of Laplace transform, right? So viewers, in this lecture, we'll see how we can apply the concept of Laplace transform to evaluate integrals of this type, right? So let us start. So let us take this integral as I, right? Now see here we have the variable t and the integrand is t raised to 4 e raised to minus t. So what we will do, let us write this integral as 0 to infinity and we have t raised to 4 and e raised to minus st, right? And here we have introduced this parameter s because we are going to use the concept of Laplace transform, right? So here we are writing as e raised to minus st. So when we take s is equal to 1, then this integral reduces to this one, right? So once we take the value of s is equal to 1, then we can readily get this integral, right? Okay, now let us rearrange these terms, right? So we can write 0 to infinity. Let us write here e raised to minus st and t raised to 4 dt, right? And now here we have this function t raised to 4. So let us take this function as f of t, right? So f of t is t raised to 4. So now we can write this integral as 0 to infinity e raised to minus st, and here we have f of t dt, right? So we have written f of t for t raised to 4, right? And now we can see that this is the definition of Laplace transform of f of t, right? Because see, we know that the Laplace transform of f of t is given by L of f of t, and this is given by the integral 0 to infinity e raised to minus st f of t and dt, right? So this is this integral is now the Laplace transform of f of t, right? So we have converted this integral into the Laplace transform of this function, that is t raised to 4. So now we have the Laplace transform of f of t, and f of t is t raised to 4, right? Okay, now we have to just find out the Laplace transform of t raised to 4. For this will use a standard result, that is the Laplace transform of t raised to n is given by factorial n divided by s raised to n plus 1, right? So this is a standard result from Laplace transforms, right? So here we see that we have t raised to 4, so the value of n is 4. So we have 4 factorial, this is n factorial, so we have 4 factorial divided by s raised to 4 plus 1, right? So 4 factorial is 4 times 3 times 2 times 1, and here we have s raised to 5, right? So this is 4 3s are 12, 12 2s are 24 divided by s raised to 5, right? Now see, here we wish to find out the value of this integral. So what we will do, we'll again replace s by 1, right? So taking s is equal to 1, we get this integral, right? So 0 to infinity t raised to 4 e raised to minus t dt, and this is 24 divided by 1 raised to 5, right? So here we are replacing s by 1. So this is simply 24. 1 raised to 5 is 1, so this is simply 24, right? So the value of this integral is equal to 24. So viewers, this is how, by making use of the concept of Laplace transform, we can solve these type of integrals, right? And this is a very nice application of Laplace transform. Hello viewers, in today's class we are going to discuss one important integral using the concept of Laplace transform, right? And we have already solved a number of problems related to the concept of Laplace transforms in our earlier videos. And in this lecture, we'll solve this integral with the help of Laplace transform, right? So let us start. Now see, here we have the integral 0 to infinity t raised to 5 e raised to minus 2t dt, right? So let us see how easily we can solve this integral by the concept of Laplace transform, right? So here let us first take this integral as I, right? So now let us rewrite this integral as 0 to infinity t raised to 5, and let us take here e raised to minus st, right? And here what we have done, we have replaced this 2 by s, right? Or in other words, we can say that if we take s is equal to 2 in this integral, then we will get this one, right? So now we have this integral. So now let us write this integral as 0 to infinity e raised to minus st and f of t dt, right? So what we have done here, we are writing f of t as t raised to 5, right? So now this integral is written in this form. Why? Because see, here f of t is t raised to 5 and e raised to minus s of t. So when we take s is equal to 2 and f of t as t raised to 5, we'll get this integral, right? And now we can see that this is nothing but the Laplace transform of f of t by the definition of a Laplace transform, right? See, if we have a function, say f of t, then the Laplace transform of f of t is defined as f of s, and this is given with the help of this integral, that is 0 to infinity e raised to minus st, and here we have f of t dt, right? So now our this integral is reduces to the Laplace transform of f of t provided s is equal to 2, right? So first we'll find out the Laplace transform of f of t in terms of s, right? So we have L, and f of t can be written as t raised to 5, right? Now here we'll make use of one important and standard result from Laplace transform, that is L of t raised to n is given by n factorial divided by s raised to n plus 1, right? So this is the Laplace transform of t raised to n, where n is some positive number, right? So n is 1, 2, 3, and so on, right? So the Laplace transform of t raised to 5 is given by 5 factorial, because n is equal to 5 here, and we have s raised to 5 plus 1, right? So 5 factorial is 5 times 4 times 3 times 2 times 1, and here we have s raised to 6, right? So the product of all these numbers is 120, and here we have s raised to power 6, right? Now see, we have to find the value of this integral, and we have expressed this integral like this, that is t raised to 5 e raised to minus st, right? So when we take s is equal to 2, then we get the value of this integral I as 120 divided by 2 raised to 6, right? So 120 divided by 2 raised to 6 is 64. So writing this fraction in the simplest form, we have 8 15s are 120, then this is 8 8s are 64, right? So the value of this integral is equal to 15 divided by 8, right? So viewers, this is how by the application of Laplace transforms, we can solve these kind of integrals in an easy way, right? Hello viewers, in today's class we are going to discuss a very important integral known as Dirichlet integral, right? So in this lecture we'll prove this important integral, that is 0 to infinity sine t over t dt is equal to pi by 2, right? So this integral is the famous Dirichlet integral, right? And here we'll solve this integral with the help of Laplace transforms, right? So let us start. So viewers, Laplace transform is a powerful tool for proving or to get the values of important integrals, right? So here we'll start with a very important integral of this form, that is 0 to infinity, and we have e raised to minus st and sine t over t and dt, right? So in order to prove this integral, we'll start with this one, right? See, here we have sine t over t, right? And here also the integrand is sine t over t, and here we have an extra term, that is e raised to minus st, which appears in the definition of Laplace transform of some given function, right? So when we take s is equal to 0, or in other words, if we take s is equal to 0 in this integral, then this integral reduces to this one, right? See, when we take s is equal to 0, we get 0 to infinity e raised to 0 sine t over t dt, and e raised to 0 is 1. So we have this integral, that is 0 to infinity and sine t over t dt, right? So what we will do here, we'll start with this integral, right? And we'll try to use some important properties of Laplace transform to arrive at this integral, right? So now we take this integral and let us take this function, that is sine t over t, as f of t, right? So we'll take f of t is equal to sine t divided by t. So now this integral becomes 0 to infinity. We have e raised to minus st, and here we have f of t, right? And now we can see that this integral is the Laplace transform of this function f of t, right? Because we know the definition of Laplace transform of some function, say f of t, is equal to capital F of s. So capital F of s represents the Laplace transform of f of t, and capital F of s is given by this integral 0 to infinity e raised to minus st, and here we have f of t dt, right? So now this integral becomes the Laplace transform of f of t. So let us take f of t as sine t over t. So we have Laplace transform of sine t divided by t, right? So what we are doing here, we have this integral, right? And this integral is now equivalent to the Laplace transform of sine t over t. So it implies that now we have to find the Laplace transform of this function sine t over t, so that that value is equal to the value of this integral in terms of this parameter s, right? So now let us take this function sine t as g of t, right? So here we are taking this solution in a step-by-step manner. So let us take this function only sine t as g of t, right? So now the Laplace transform of sine t over t is now the Laplace transform of g of t divided by t, right? And now here we'll use an important result from Laplace transform. So viewers, we have a very important result from Laplace transform, that is the Laplace transform of gt over t is given by this integral, that is s to infinity, and here we have capital G of s ds, right? So this is an important result in Laplace transform, right? And here this g of s, the capital G of s, is the Laplace transform of this function g of t, right? So here we have g of t. Now see, the Laplace transform of g of t implies that the Laplace transform of sine t, right? And again we know an important result from Laplace transform, that is Laplace transform of sine at is given by a over s square plus a square, right? And if we take a is equal to 1, then the Laplace transform of sine t, right? So if we take a is equal to 1, so we have 1. Here we'll take a is equal to 1. So we have s square plus 1 square, that is 1 over s square plus 1, right? So the Laplace transform of sine t is 1 over s square plus 1, right? So now this Laplace transform of g of t over t is given by this integral, right? That is s to infinity, and here we have capital G of s, which is the Laplace transform of g of t, that is 1 over s square plus 1, right? So now we have to evaluate this integral. So to evaluate this integral, we'll again use an standard result from indefinite integrals, right? See, we know that dx over x square plus 1 is simply a tan inverse of x, right? So here the parameter is s. So we have the integral, indefinite integral of 1 over s square plus 1 is tan inverse of s by virtue of this result, right? And here we have the limits s to infinity, right? Now we'll take the we'll substitute the limits and we'll take the difference. So we have tan inverse infinity minus tan inverse of s, right? And we know that tan pi by 2 is not defined, so that pi by 2 is the tan inverse of infinity. So here we have pi by 2 minus tan inverse s, right? And here we'll use an important result from inverse trigonometric functions. So from inverse trigonometric functions, we know an important property, that is tan inverse theta plus cot inverse theta is equal to pi by 2, right? So if we take this term to the right hand side, we have cot inverse theta is equal to pi by 2 minus tan inverse theta, right? So here we have pi by 2 minus tan inverse of s, right? So if we replace theta by s, so this quantity is now equal to cot inverse s, right? So viewers, the value of this integral I is now equal to cot inverse of s, right? So this is a very nice result, right? So the value of this integral, that is 0 to infinity e raised to minus st, and here we have sine of t over t dt is equal to cot inverse of s, right? So when we take s is equal to 0, then this term becomes 0, 1, right? So if we take this s as 0, then e raised to 0 becomes 1. So we have now 0 to infinity sine t over t dt is equal to cot inverse of 0, right? Because we are taking s is equal to 0. So we have cot inverse 0. And from trigonometry, we know that cot inverse 0 is equal to pi by 2, right? Or in other words, cot pi by 2 is equal to 0. So this quantity is equal to pi by 2, right? And this is the required result, right? So the value of this famous Dirichlet integral, which is 0 to infinity sine t over t dt, is equal to pi by 2, right? So here's, this is how by making use of the concept of Laplace transform and its properties, we can arrive at these type of the result of these type of important integrals.